Today I'm going to show you the physicist way of expanding 1 over 1 plus x or 1 over 1 minus x, but using a physicist way of doing that. So, binomial expansion. It has the following form: 1 over 1 minus x is given as, this is the claim, 1 plus x squared plus x cubed, and it goes like that. So obviously you can prove this rigorously, but what I'm going to do instead is, again, the physicist way of checking it, checking whether it's true or not. So what we do is we multiply both sides by 1 minus x. So I'm going to multiply the left and the right by 1 minus x. And if I do that, this is going to cancel that. And the left-hand side would be equal to 1. And the right-hand side, I'm going to multiply everything by 1. So that's 1 plus x squared. It's going to go like that, right? And then I'm going to subtract minus all of that multiplied by x. So I'm going to subtract all of the series multiplied by x. So x times 1 is x, and x squared, and x cubed, and it goes like that, right? So you see that these guys cancel at each order. So x squares cancel, x cubes cancel, etc. All of the terms cancel. And you are left with 1. So 1 is equal to 1. Okay? So this is a physicist way of checking, not proving, the correctness of 1 over 1 minus x. I could have left the constants in front, like all of them are 1, and I could easily figure out those constants using these conditions that were stepped, and I can build it from the cancellation to the expansion. And I can write this as a series expansion, so that's 1 over 1 minus x is therefore, I can write this as 1x, so you start from n is equal to 0 to infinity, so it goes like, all of them are positive, so there's no power of 1 in here, not necessary, and that's x to the n, and it starts from n is equal to 0. Yeah. So you see 1 over 1 minus x is equal to n goes to 0 to infinity, x to the n. Okay? And the next expansion is just 1, this time I'm going to do 1 plus x. So 1 plus x is equal to 1 minus minus x. So what I'm trying to do is, I'm trying to use this expansion, which I already showed that it works, not repeat all this procedure again, and just replace this 1 plus x with 1 minus a term, and now it's 1 minus minus x, right? So that's why I can use this expression, the same expression for 1 plus x, because this is nothing but 1 minus minus x. So wherever I see x, I'm going to replace that with minus x. So again, the series goes from 0 to infinity. So now it's minus x to the power n. Okay, or I can write it as, sometimes we write it as n is equal to 0 to infinity minus 1 to the n. We just take minus 1 out of this and then simply write x to the n in here. So that's minus 1 times x to the n, which is same as that. So that's 1 divided by 1 plus x. Okay? So this is a nice, I think, a demonstration of, again, not proving, but physicist way of checking the binomial expansion for these two things.